This is Engage New York, Module 1, Lesson 13. Read the objective out loud while I read it. I can divide decimals by single-digit whole numbers. Such a great lesson. Anyway, we're going to go ahead and start with a sprint, and our sprint is subtracting decimals. So you're flipping over, you're looking at side A, pencils up. Show me when you have your pencil up. Daphne is ready. All right, you guys. 1, 2, 3, go. All right. 4, 4.9, 4.93, 4.932, 3.932, 1.932, 0.4, 0.43, 0.439, 8.439, 8.339, 8.139, 0.04, 0.047, 1.047, 1.856, 1.817, 0.004. All right, second side. Pencils up. Ready, go. All right, let's go over 5, 5.9, 5.93, 5.932, 4.932, 2.932, 0.5, 0.53, 0.539, 8.539, 8.439, 8.239, 0.05, 0.0757, 0.057, 1.857, 1.847, 1.827, 0.005, 7.005. Did anyone go farther than that? Here we go. Concept development, Engage New York, Module 1, Lesson 13. Let's go ahead and get started with our concept development. So we have added decimals, we have subtracted decimals, we have multiplied decimals, and now we are going to divide decimals. All right, using the same concept as what we were using for, I guess, our strategy, if you will, by using the place value chart, let's go ahead and do a few problems. Are you ready? Our problem, number one that we're going to start with is 0.9 divided into 3 equal parts. So we are going to have 3 equal groups, and we have to take 9 and divide that up into 3 equal groups. So 9/10 divide by 3/10, right? So there are 3 groups of 0.3. So if you had 0.3, like think about the repeated addition, 0.3 plus 0.3 plus 0.3, that would equal 0.9. There are 3 equal groups of 0.3 and 0.9. Yes? Make sense? Give me a thumbs up if that makes sense. So 9/10 divided by 3 is 3/10. So how does unit form help us divide? And when I say unit form, I mean this. How does unit form? Well, when we identify the units, then it's just like dividing 9 apples into 3 groups, just like whole numbers, dividing whole numbers. So 9/10 divided by 3 is 3/10. So 3 groups of 0.3 equals 0.9. So by going into unit form, it's like you're taking out the decimal and you're just worried about the numbers, 9/10, and you know the word tenths is in there. So you have to have 3 0.3s to make 0.9. All right, problem. So if I were to do this in using a place value chart, here are 0.3, 0.3, 0.3. It takes, you add those up. If you were to add those up, you would end up with 0.9. All right. So you're just dividing it up into equal groups. Now let's move on to problem 2. So I have 0.24. I have 24 altogether, and I'm going to divide it into 4 equal groups. Now, what would make sense if I had 24, 0.24, and I had to divide 24 into 4 equal groups? What would I divide them up into? Yes, 0, 0.06. So we are going to have, we have our ones, we have our tenths, and we have our hundreds. Now remember, 24 would be sitting in this section, right? 0.24. Yes? All right, so now let's break that up. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Here's one group of 6, a second group of 6, a third group of 6, and a fourth group of 6. If you were to add them up, you would end up with 24. You'd have to move 2 tens over here and end up with 24 left over. So 24, let's write it this way, 24 hundredths divide by 4 is going to give us 0.06. We have 4 groups. So this equals 4 groups of 0.06. Okay? And then if we were to add it up, we went 0.6, 0.6, 0.6, 0.6, and that would equal 24. 1, 2, 3, 4. 4. And it needs to be 0 point. The zero, the decimal point needs to be here. Excuse me. Excuse me there. All right. Are you starting to understand a little bit how we're breaking these numbers up? So let's move to problem 3, 0.032. So this is like 32 tens, hundreds, thousands. This is 32 thousandths divided into 8. So if I subtracted it 8 times, so if I went 0.032 and I would subtract, I have to subtract by some number 8 times. What number do you think that would be if I would? Thank you. Thank you. Show me with your fingers. What number are you going to subtract by over and over and over? What number are you going to subtract by 8 times? Thank you. So you're going to subtract by 0.004, and that's going to give you, I'm going to subtract. So if I took 32 and I subtracted 4, what is that going to give me? So if I subtract it again, 28 subtract 0.028 subtract 0.004, I'd end up with 0.024. Subtract that by a 4 again. So here's once, here's twice, here's 3 times. I'd end up with 0.020. subtract again 0.004. That would be a fourth time. Subtract again. Oh, well, that would give me 16, right? 0.016. Subtract 0.004. That would be a fifth time. 16 subtract 4, that would give me 12. 0.012 subtract 0.004. That would be my sixth time. Then I would end up with 0.008, and I subtract 0.004. That would be my seventh time. Then I end up with 0.004, subtract 0.004. That gives me to 0. Yes, we subtracted by the same number 8 times and took me all the way back to 0. And I have now 8 equal groups of 0.04. How does that feel? Problem 4. 1.5 divide into 5 equal groups. So if I got rid of the decimal and I multiplied by 10, right? Got rid of the decimal, or I went, this equals to 15 tenths, and I'm going to divide 15 tenths by 5. So I'm going to divide 15 tenths into 5 equal groups. I'm going to have 1, 2, 3, 4, 5. I have 5 equal groups of 0.3. So 15 tenths divided by 5. So 5, this would be 5 tenths, is 0.3. All right. So if you 1.5 divided by 5, if you multiplied that by 10 and you got 15 divided by 5, it would equal 3. Then if you had to divide back and throw that decimal back in, you would end up with 0.3. All right. Problem 5. 1.05 divide into 5 equal groups. Or 10, this would be really easy to do, 10 tenths and 5 hundredths. Might be easier to divide because they are both multiples of 5. So 100 or 105 hundredths divided by 5, or 10 tenths and 5 hundredths divided by 5. So 5 divided by 5 would be one group of 5. And then tenths divided by 5, 10 divided by 5 is 2 groups of 5. 10 divided by 2 groups of 5. 1, 2, 3, 4, 5. 2 groups of 5. So this ends up with 2, 1. So if I put my decimal down, I have 0.21. 0.21. We will get to standard algorithm tomorrow, but I'm really getting you to put everything together that we have already learned. We've already learned about using the unit form. We're getting used to breaking numbers up into equal groups, whether we're multiplying or dividing. And now we're just breaking it up in a new way. Okay. Problem 6. All right. How many in each group if I have to divide it into 5 equal groups? That is the big idea. How many will be inside each group? Now, I want you to remember when you were learning multiplication. You were learning multiplication by using arrays. And arrays, this is basically how we're breaking things up. Remember when you multiplied 1, 2, 3, 4, let's say 5, when you multiply 5 by 1, 2, 3, 4, and you knew inside there would be 20 altogether, right? Well, now we're moving from going with 20 altogether, and then we're going to divide it into different groups. All right, so hopefully that is ringing a bell for you. So let's change this 3.015 divide into 5 equal groups. Well, you could go 3,015 thousands, because you could just multiply and get rid of that decimal. Divide by 5. Another way might be to go, what about 30 tenths and 15 thousandths? Now, wait a minute. Those numbers are nice to work with, and those are multiples of 5, and that works out really nicely as well. So let's divide by tenths into 5. We'll divide 30 tenths into 5 equal groups. Then let's divide 15 thousandths into 5 equal groups and see what we get. All right, are you ready? So we're breaking down our answer into 5 equal groups, and we're breaking this into 30 tenths and 15 thousandths into a much smaller, easy bite-size division problem. So 30 tenths divided by 5. So how many, show me with your fingers, how many are going to be in each group? Excellent. Okay, so I'm going to take 30 and I'm going to put it into 5 equal groups, and I'm going to put it in the tenths. So I'm going to have 6 in each group. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I got one more. 1, 2, 3, 4, 5, 6. So I have 1, 2, 3, 4, 5 equal groups, and I have 30 all together. And notice they look like an array, and the array is something you learned back in 3rd grade. Now, let's take our 15 thousandths and break that into 5 equal groups. 15 5 equal groups. How many are going to be in each group? Show me with your fingers. There are going to be 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. I have one more. 1, 2, 3. Now, if I went 3 times 5, that's 15. So I have broken this up. So how many do I have here in the middle? I have 0. So if I say 3.015 divide into 5 equal groups, what is my number going to be? We'll break down to 5 groups. So we're going to have 1, 2, 3, 4, 5. But how many are inside each group? Well, here there are 6 in each group. There's 0 here, and there's 3 here. So we have 3.015 divided equally into 5 equal groups, and we end up with 0.603. So I have 5 groups of 0.603, 0.603, 0.603. 1, 2, 3, 4. I need one more. So if I have 5 groups of 0.603, if I were to go back and add them all up, guess what I'm going to end up with? 3.015. So in each group, there is 0.603 in each group of 5. So finding relationships between all 3 problems, like 4, 5, and 6, well, finding the relationship would be to separate. You have to separate them into equal groups. And I have to say, I really like this strategy of breaking it up into something that's bite-sized, something that's easy to see. All right, just really quick. If I have 4.8, and I'm dividing it by 6, I wonder what I'm going to break this up to. I wonder how much will be in each group. But wait, I have 48 divided by 6. How much is 48 divided by 6? Show me with your fingers. What's 48 divided by 6? Yes? You guys good?